Okay, so let's look at number 47 from the Calculus Chapter 3 packet. So in this one, we're trying to find, this is actually working backwards. I give you the tangent line right here. So this is the equation of the tangent. And what you're trying to do is find out stuff about the original curve. So root x times some constant still looks essentially like a root x function. If c is positive, it's going to do this. If c was negative, it would go upside down instead. Let's just pretend that it looks like this for now. And then somewhere the tangent line has this equation. It's a positive slope, so let's say it hits right here. And this blue line that I'm graphing has the equation 3 over 2x plus 6. And I don't actually know where this hits, so I'm just going to make up a value for it and call it a comma f of a. Well, in fact, it's a comma whatever I get when I plug in a into here, which is c root a. But notice it's also on the tangent line. So I could call this point a comma whatever I get when I plug in a into the tangent line equation, which is 3 over 2a plus 6, because it's on both of those lines. So what I can do from there is set those two equal to each other. C root a has to equal 3 over 2a plus 6. Okay, so let's see, how can I solve for a? Let's try. Well, actually, no. Let's do this a different way. Because that way is going to take a while. So another thing that we can do is the slope of the tangent right here is 3 over 2. Well, that's going to be related to when I take the derivative of my original function and plug in a. So y prime here, for my original function, y is c root x. And so y prime is going to be, actually, let me write that as cx to the 1/2 first. So then y prime is going to be c times 1/2 x to the negative 1/2. And if I simplify this, it's like a c over 2 root x there. So that's the derivative of the square root function that I have. So what I want to do now is I know that y prime at a is 3/2. So if I plug in a into this function, my slope function, I get that. And then I can simplify this a little bit. So if I multiply both sides by 2, I get 3 equals c over root x. And then if I multiply the root x over, I get c. So now I know c is 3 root x. Actually, I didn't plug in a. These are a's, not x's now. So a here, a there. So 3 root a equals c. Okay, so what can we do with that? 3 root a is c. Then I can say that this point now is really a comma, and instead of c, it's 3 root a and then times root a. So this right here is really just 3a. And I also know that it's equal to this. So 3a right here and 3/2 a plus 6 are going to be the same. So at this point, I can set this up. I know that 3a has to equal 3 over 2a plus 6. So if I subtract 3 over 2a from both sides, so it's 3 minus 1.5a, which is still 1.5a. So it's 3 over 2a equals 6 at this point. And then if I multiply both sides by 2/3, I'm going to get 6 times 2/3, which is going to end up being 12 over 3, which is 4. So I know this happens when a is 4. So this point right here is 4, comma, and then if I plug in 4 either into the 3a or the 3/2 a plus 6, I'm going to get 12. So now I know that my tangent line at 412 has this equation. Okay, so tangent line y equals 3 over 2x plus 6 occurs at 4 comma 12. Okay, well I need c. So I also know that 412 has to work in my original equation. So y equals c root x, I should be able to plug in 4 for the x and 12 for the y and solve for c. So 12 equals c root 4, which is 2c. So therefore c ends up having to be 6. And this is only one way of doing it, but I think it's probably the one that involves the least complicated set of calculations. There's another way of doing it, but involves some completing the square in there and some factoring and some really ugly numbers along the way. So this is going to be the simplest way of doing it. It's not a simple problem because it really requires you to work kind of forwards and backwards at the same time.